Okay, class, so here we go with e-learning day 3. Hopefully we are staying caught up. It's so important that we do not get too far behind. We should be putting this in our notebooks when we come back. Whenever I see you again, we will be checking notebooks. Okay, so in your notebook, we're going to be, this is going to be talking about relations and functions. And the date for this is going to be Thursday. March 19th. So first piece to understand here is we're talking about a large category that we call relations. So everything within this entire thing is relations. And some of those relations are going to be very specific, and we will call those functions. So we're going to look at this large grouping first, where a relation, okay, is anything that we can represent as ordered pairs. Okay, so an ordered pair is always something that we write in parentheses, where we have an X value followed by a Y value. But that X and Y value can represent anything. So it could be letters, it could be numbers, it could be your favorite color for the X column, and how many cookies you ate yesterday for the Y column. It really can be just about anything. Okay, so maybe we decide we want to do some representations of ordered pairs, and I'm just totally making these up. Okay, and this is going to be our information. We should then understand that we can represent this information in several different formats. So option 1, obviously, is that we can represent it as ordered pairs. Okay, option 2 is that we can take this information and we can represent it in a table. So we can take this exact same information and put it in a table where our X values are on the left, or our first number in the ordered pair is on the left, and our second number in the ordered pair is on the right. So literally all we're doing is picking up each ordered pair. So I'm taking 2, 7, and I'm putting it in here as 2, 7, right? 4, 3, -1, 6, and 4, -1. Okay, so a table is a second representation. A third representation that we can use is plotting points on the coordinate plane. So this is something we should be able to do. However, if it's something that you're not super great with, I'm going to give you a couple reminders here. On a coordinate plane, your x-axis is your horizontal. Your y-axis is your vertical. Again, like we said, an ordered pair is always x first, y second. So if I want to plot 2, 7, I'm always going to go on my x-axis to 2 first, and then on my y-axis to 7 second, and I'll just make a point there. Okay, then I'll plot the point 4, 3. So I'm going to 4 on the x, and then 3 on the y. I'm going to -1 on the x, and then to 6 on the y. I'm going to 4 on the x and to -1 on the y. And if that happened too fast for you, feel free to pause or rewind or whatever you need to sort of get that copied over. The third option that we can do is what my students sort of think of as the weird one. Okay, the third one that we can do is called a mapping. And a mapping consists of 2 sort of columns. Okay, our left-hand column and our right-hand column. We just have some specific rules about what we can write in each column. So in a column, we can list no repeats, and it has to be in numerical order, so from least to greatest. Okay, and on the left, I'll put my left column, which is all my X values. I can either get those x values from the ordered pair, or I could get those x values from the table. It doesn't matter. We should be able to work between all the representations fluidly. Okay, and I'm going to list them without repeats in numerical order. So my smallest x value is -1. My next one is 2. And then I have 2 4s, but again, I'm not allowed to list a repeat. So I'm only going to write that 4 down one time. Okay, then on the right-hand side, I'm going to do the same thing, but with my y values. So -1 is the smallest, then 3, then 6, then 7. Okay, and I'm sort of just now going to connect the dots. So I'm going to draw a line between the two numbers that go together. So 2 goes to 7, 2 comma 7. So I'm going to draw a line from 2 to 7. 4 comma 3, right? I'm just going across with my ordered pairs here. -1 goes to 6. And then 4 goes to -1. So now I'm just drawing a second line from 4 to the other value it goes to. Okay, so whenever we are talking about a relation, we can always represent it in these 4 options. We can do ordered pairs, a table, a mapping, and we can graph it on the coordinate plane. Now, if we are talking about a specific type of relation, okay, that specific type of relation is called a function. Okay, and a function has all the same properties that we just talked about. The difference is that a function has no repeats in the x value. Okay, a function has no repeats in the x value. So this problem that we were just looking at would not qualify as the specific type of relation we call a function because this x value happens twice. It repeats. So this is not a function. So a function has no repeats in the x value. So there are some things that we talk about with functions once we've identified it. We can use all those same representations, but we're just going to be sort of narrowing our focus. Now, the first thing is that we have to identify if it's a function. So let's say we were given this table. Okay. So if we were given this table where we have 4, 2, 5, and 6 down the x column, and 3, 8, -1, and 3 down the right column. And we wanted to decide if this was a function. Again, the rule is that it has no repeats in the x value. So the y value isn't important. So I'm just looking over here in the x value and then deciding if I see any repeats. I do not see any repeats, so this is a function. So if I said, is this a function? We would say yes. Okay, it is a function. It's also a relation. It's just the specific type of relation we call a function. Okay, maybe if we had this and we were looking at a mapping. Now, we would not see any repeats happening over here in the x column. Again, it doesn't matter what happens in the y. We're not going to see any repeats because our rule was that we couldn't write down any repeats in a mapping. So instead, what we're looking for is to see if a number has 2 lines coming from it. So this 7 has 2 lines coming from it, which means it would be used twice. So if there's 2 lines coming from it, we would say, no, it's not a function. Now, if everything only had 1 line coming from it, then we would say, yes, it is a function. Okay, we can also look at ordered pairs. Okay, if we wanted to decide if this is a function, again, we would be looking at the x values only. So if I'm looking at the x values, right, that's my first number. So while I see a repeat here, those are y's, and y's don't count when I'm determining if it's a function. So I don't see any repeats in the x value. So since there are no repeats, I would say yes, it's a function. Okay, so now if we're gonna do a mapping, not a mapping, a graph, if we want to turn from a graph, we have a little bit different rules because we're not gonna see numbers. So if we're looking at a graph, we have to do something called a vertical line test. Okay, and a vertical line test is just a way to visually decide if an x value repeats. Okay, so if we're given a graph, so let's say this is my coordinate plane. And maybe I have this line graphed across it. Okay, what I want to do is I want to take something, imagine a vertical line going up and down. So maybe your pen or a pencil, something that creates a vertical line, right? Vertical is up and down. And I want to see if there's any place on this entire graph, all the way across, that I can get this orange graph to touch my pencil twice, right? So it only touches once, only touches once, only touches once, right? Every vertical line I'm drawing here is only touching the orange graph once. If it only touches one time, then we would say yes, it's a function. To see if I can actually spell today. If we can ever get it to touch twice, so maybe instead of it being a line, maybe I just have an assortment of dots. Maybe some of them are open dots. Maybe some of them are attached to something. Maybe they make lines. It doesn't really matter. Okay, decide if it's a function or not. Again, we're looking at vertical lines. So we're going to take something and we're going to look every place vertically. So if I look at the edge of this paper, right here, when I draw a vertical line, it touches these twice. So this vertical line is touching here and here. So we would say, no, it's not a function. Squeeze that word in. Now, be careful because remember our rule says if there's someplace that we see an open circles, the graph is not actually there. So if this was a location and I was drawing a vertical line, this doesn't touch twice because this doesn't count as having graph there. So make sure you're really finding two solid circle locations. Okay, then the last thing that we need to consider is just some other things that we can talk about with representations and key terms, and they're both really quick. So these should be the points that you always get. Okay, so one thing that we can do with relations and functions is we can find an inverse. An inverse is just where we switch the x and y value. So if I have the ordered pairs 2, 7, -3, 8, and -1, 4, these braces, guys, we're going to talk about in a minute, but they're just how we group things together. Okay, the inverse says just switch where the x and y are. So this is going to go to a 7, 2, and an 8, -3, 4, -1. So that's all there is to an inverse. I'm just swapping where the x and y value are. Okay, the other piece that should be something we always get the points for is if we are asked to list the domain and the range. This is just a matter of knowing the vocab, so get this copied down in your notebook. Okay, your domain is your x values, so the first number in an ordered pair. We list them in numerical order. We list it with no repeats. And we list it in braces. In the math world, these braces are just our grouping symbols. So it's just a way that we hold something together. We say that they belong together as a set. Okay, a range gets the exact same rules. Except now, instead of saying it's our X values, it's our Y values. So it's in numerical order. We have no repeats. And it goes in braces. So just sort of a lot of rules. This is the benefit of being able to use your notebook on anything, right? Just knowing the proper way to write it down. So if I have this as my set of info, as my relation, and I want to write down the domain and the range. Again, the domain is the X values. So I'd be picking all of my X values. I would be writing them in numerical order. So the smallest is -2. Then is 4, but there's 2 of them, so I can only write it one time, right? No repeats. My last one is 7, and it needs to go in braces. My range will then be all of my Y values. In numerical order, so -3 is the smallest, -1, 5 and 7, and then that also goes in braces. Okay, so I realize this is a lot of information today, but it's really just a lot of sort of basic rules. So we need to make sure we have that all in our notebook so that when it comes final exam time, you say, oh man, I kind of forget or whatever, right? You could just go back and look through your notebook and remember those rules really quick. So you need to log into Aleks. You need to do your exit slips for today. It's the e-learning that's marked for today. You need to go through and do those problems. If it takes you less than 10 minutes, work on your pie so you make sure you get your time done for this week.